Hey guys, we're going to work on solving measurement conversion problems using ratios today. Fourth grade, we talked a lot about measurement. Remember King Henry and the metric system, plus pounds, inches, cups, quarts, all that kind of stuff. We didn't talk about all those being ratios last year, but they are ratios last year. And so I'm going to tell you how to solve measurement conversion problems using ratios today. So mark your next page in your math notebook. And put the pencil inside, close it up, and listen carefully for the I do. So just to remind you, we have lots of units of measurements to measure the same things, like, for instance, height. This is my height. We commonly talk about our height in feet, or feet in inches. I'm 6 feet tall, but I could just as easily say I'm 1 8/10 meters tall. Same height, different unit feet meters. I also weigh about 170 pounds, which is what we usually talk about our weight in, but I could just as easily say I weigh 77 1/10 kilograms because that's the same weight, excuse me, with a different unit of measurement. And so if you wanted to think about it now that you're a ratio expert, I've got a ratio here for every 170 pounds somebody weighs. They weigh 77, a little more than 77 kilograms. For every 6 feet tall someone is, they're also 1 8/10 meters tall. And so we're going to think about things like this as ratios today. So there are typically questions like this come in a nice, easy form where they give you a unit rate, which is really nice because once you know a unit rate, it's really easy to find conversion problems. So we'll do an easier one and then one just in case they didn't give you a unit rate to practice that way too. Let's do this one. So, example, lots of people run a 5K race. You've probably heard, I'm going to run a 5K or do a 5K. How many miles is a 5K? And in these kind of problems, you don't have to worry about memorizing any conversions. They'll give them to you. But we want to solve this. How far is a 5K, which is 5 kilometers, if you've never heard that term before. And a mile is equal to about 1 6/10 kilometers. It's a little more than 1.5 kilometers make a mile. So here I've got a unit rate given to me. I know that 1 6/10 kilometers makes put my unit in there, makes 1 mile. And I can use that to figure out 5 kilometers. Well, how far is that? Right? Basic ratio. And so I'm going to go from here to here. I've got to figure out what am I multiplying 1 6/10 by to get 5. So let's figure that out. 5 divided by 1 6/10 gives me times 3 125 thousandths. 3 125 thousandths. So I'm going to multiply the same down here. And it's nice with a unit rate because you always have a 1. So it makes for kind of an easy multiplication. So I know that since this is the ratio 1 mile, every time I run 1 mile, I run 1 6/10 of these. That means in that same ratio, if I run 5 of these, I run 3 125 thousandths of a mile. Lots of times you'll just hear people put it at 3 1/10, but technically it's a teeny bit longer. All right, so not always do they give you a unit rate. I want to do another one, but I'm not gonna give you a unit rate. I'm gonna give you just a really good, accurate ratio. So the heaviest watermelon ever, and I did look this up, weighed 159 kilograms. That's the Guinness Book of World Record watermelon. How many pounds is that? I found this handy little chart. If you look at this pounds to kilograms, this is a double number line with kilograms on the bottom and pounds on the top. And you'll notice right here that 10 kilograms lines up perfectly with 22 pounds. And if I make another set of that, 20 kilograms lines up perfectly with 44 pounds. And so that's my conversion. Rather than knowing what 1 pound is, because that's, I can tell it's a fraction, but I don't know what, or telling what 1 kilogram is. It's more than 2 pounds. Sometimes you'll just get a ratio like this, like 10 to 22. So I know that for every 10 kilograms something weighs, it also weighs 22 pounds. Pounds is lb. It's Latin. And we want to know, we know the kilograms in the question, so we want to know for a 159 kilogram watermelon, how many pounds was that? So I'm sticking with proportions here. I could go back to that double number line and try to tell where, it doesn't even go up to 159. Never mind. If I did, I could make a double number line. I'm just going to stick with this strategy because it's the quickest usually for me. So I need to figure out what am I multiplying 10 by to get there. And let's see. Oh, I should be able to do that without a calculator. 159 divided by 10 is just move the decimal one spot. 15 and 9 tenths. That's how that works. If I divide this by 10, I just put the decimal there. If I divide it by 100, I would just put the decimal there. That was easy. So I'm going to multiply the denominator by the same. 15 and 9 tenths. 22 times 15 and 9 tenths. And I get 349 and 8 tenths pounds. Basically, a 350 pound watermelon. Yum. All right, so that's how they work. They're just ratio problems like any other. Frankly, they're not too different. So let's do a couple together. We'll do, again, one where you get a unit rate, and then we'll do one where you don't get a unit rate. So let's start here. A typical sheet of paper like that you put in the printer is 11 inches long. How many centimeters is that? And I'm going to give you the conversion from inches to centimeters. If you want to see it, I found that one too. Like on a ruler, 1 inch is pretty much 2.5 centimeters. It's a teeny bit more, 54 hundredths. As you can see, there's not really any place where a centimeter and an inch lines up perfectly like there was on, that's pretty close, 28 centimeters and 11 feet. But there's no perfect lineup, so usually you get this conversion will just be given to you. So I know that 1 inch is equal to 2 and 54 hundredths centimeters. And I want to know for an 11 inch sheet of paper, how many centimeters is that? Well, that's going to be easy to figure out because I love unit rates because it's really easy to figure out what I multiplied by. So that's times 11. So that's times 11. And 22. 2 and 54 hundredths times 11 times 11 is 27 and 94 hundredths centimeters long. Oh, and that's the one I showed you. That's the 11 inches is really close to 28 centimeters. Look at that. It's like a teeny bit less than 28 centimeters, and we just figured that out. How about that? All right, let's do one more where they don't. So a marathon, you may have heard the word marathon. A marathon is a long race. It is a little more than 26 miles. How many kilometers is that? So the common conversion from miles to kilometers is that 5 miles is equal to 8 kilometers. Those are the measurements that pretty much line up. So if you run 10 miles, you run 16 kilometers, 15 miles, 24 kilometers, and so on and so forth. They come in about that ratio. So marathon, we know the mileage is 26 and 2/10. So we then want to know how many kilometers that is. There's more miles than kilometers, so it's going to be more than this. So I don't know how to multiply 5 to get that. So I got to figure it out. Looks like a little more than 5. That makes sense, right? 5 times 5 is 25. So 5 times a little more than 5. Did I write that down right? Is a little more than 25. And then I got to multiply that by the same thing. Times 8 is 41 and 92 hundredths kilometers. You usually hear a marathon referred to, people usually round these, and they usually say a marathon is 26 miles and it's 42 kilometers. That's what you usually hear. Technically a little more than that in miles and a little less than that in kilometers. But that's it. They're just simple ratio problems, just like any other, but they're common, so I wanted to spend the time showing you how they work. Once you understand the examples we did and you've written these ones down, you're all set, and we'll practice a few tomorrow.